Good morning. This is Grade 10 Information and Communication Technology. Talking about numbers and their conversions in this unit. Up to now, we have finished so many things. We discussed about various number systems at the beginning, and then we turned into number conversions. So remember, we have completed 10 various conversions up to now. All these conversions are very important. I told you to spend some time for practicing. Hope you all did some of the homeworks at your home, right? So without those practice sessions, you cannot remember those methods. So up to now, we have finished 10 conversions. Just remember the conversions which we finished. So at the beginning, we had 3 conversions. In all these 3 conversions, we converted a decimal number into binary, into octal, and also to hexadecimal. Then after that, we took the opposite conversions. We converted a decimal, binary, hexadecimal into decimal number system. So there we finished 6 conversions. Then we had 4 conversions. In all these four conversions, binary number system as a part. Hope you remember those 4 conversions, right? So binary to octal, octal to binary, binary to hexadecimal, hexadecimal to binary. So we have 10 conversions up to now, right? So hereafter we have 2 more conversions to be taken, because you have 4 different number systems. Every number system has to be converted into other. So when it comes to 4, 4 into 3, so definitely you have 12 conversions. Out of 12, we have completed 10 of them, right? So let's take the remaining 2 conversions today and finish them. So with this today's class, we can conclude all the number conversions, right? So I think that you guess the remaining 2 conversions, because they are not hard. It is too easy to guess. So what are the remaining 2 conversions? We have to convert an octal number into hexadecimal number system. At the same time, the opposite one. A hexadecimal number system has to be converted into octal, right? So we have 2 more conversions. In both, there is no decimal involved, there is no binary involved, only octal and hexadecimal, right? So with this small introduction, I straight away go to the first conversion, which is converting an octal number to hexadecimal. So let's see how to do this. So this is number 11, octal to hexadecimal. Right. As I mentioned earlier, we have completed 10 conversions. In all these 10 conversions, we used a direct method. In each and every number conversion, we converted a number into another directly. We didn't take many steps, many conversions. So look at them. If it is decimal to binary, we directly converted a decimal into binary. Even if it is binary to octal, we converted directly. But this is something different than which we did earlier. In all those 10 conversions, a number system has directly been converted into another one. But here, we cannot do like that. You cannot convert an octal number into hexadecimal directly. So what we are going to do is, we have to convert this number, octal number, into another number system first. Thereafter, that number should be converted into hexadecimal. So in this case, you have 2 options. Even those 2 options are very familiar to you, because we studied all the 10 conversions. To convert an octal number into hexadecimal, there is no explanation needed, there is no description needed. Even without the help of me, you can do that because you have completed all these 10 conversions. So what are the two options which we have? What is the first one? The option A is this octal number can be converted into decimal first. Thereafter, that decimal to be converted to hexadecimal. That is the first option, right? Converting this octal into decimal, then decimal to hexadecimal. That may be okay. You know how to convert an octal to decimal and also decimal to hexadecimal. We already studied. This is the first option which I named as option A. We have another option, option B. What is it? This can be converted into binary. This octal can be converted into binary. After that, that binary has to be converted to hexadecimal. That is also another option, right? Octal to binary, then binary to hexadecimal. Both are okay, both are correct. Even if you try any of them, definitely they will accept in examination. But maybe the second option, which I mentioned as option B, may be a little easier because there we convert the things into binary. So it may be easier, even you cannot make mistakes, big mistakes there. So better we will stick with the second method. But of course, those who can use the first method will get marks. There is no issue at all. Even I think your book suggests the second one, recommends the second method, converting this octal to binary, then binary to hexadecimal, right? So with this description, let's convert this octal to hexadecimal, right? So take an example first. So I take an octal number first, 753. This is octal number. Let's convert this to binary first, right? So it has to be converted into binary. Whenever you are working with octal binary, you must remember that connection, you must remember the relationship. To represent one octal digit, you need how many bits? You need 3 binary digits, right? So now look here, each and every letter is an octal letter, right? So this 7 has to be represented by 3 binary digits. Similarly, this 5 should have 3 binary digits. This 3 also should have 3 binary digits. So let's find out them. So first of all, it's 3. So I can write that computations here. 3 has to be converted to binary. So it's very simple. Divide by 2. It is 1. Remainder 1. Divide it again. Here 0 times 0 quotient. The remainder 1. So this 3 is represented by 1. But look here. To represent this 3, definitely you need 3 binary digits, but we have only 2 of them. So how can make them as 3? So add the 0 there. 0 which is placed at the beginning doesn't have any value, right? So now it satisfies that particular rule or particular theory, right? So that is correct. Now 5 should be converted to binary. So check that 5, 2 times 2 quotient, 1 remainder. Divide again, 1 quotient, 0 remainder. Divide again, 0 quotient, 1 remainder. So it's going to be 1, 0, 1. So make sure that you have 3 digits there. So here we don't have any issues because we have 3 digits, right? Let's take the third one, which is 7. So it is 3 times 1 remainder. 1 quotient, 1 remainder. right? It is 0, 1 remains. So here 1, 1, 1. Now write them together, right? Because we want a binary number, so write them together. 1, 1, 1, 1, 0, 1, 0, 1, 1, base 2. This is binary. Is it the one which you intended to get? No, right? So we are in the middle. Still long way to go. Not long way, but have to go, right? So look here, we got the binary number. But the question is about octal to hexadecimal. So we have to convert this binary to hexadecimal. At this point, you must have, or in your mind, there should be another connection appeared. So what is the connection between binary to hexadecimal? To represent one hexadecimal, you need 4 binary digits. Or in other words, 4 binary digits can represent one hexadecimal character. So now you have many binary digits there. You have to form groups to take hexadecimal digit, but make sure every group has how many bits? 4 digits, right? So we already studied about how to form the groups. From right side, you can form your groups, right? So in my last group, these 4 digits are there. 1, 0, 1, 1. In the next group, you have another 4 digits. 1, 1, 1, 0. Look here, at the beginning there is 1. Put the 1 because that must be, or that belongs to another group. 1. To take 4 digits, you need to add 3 zeros. Okay. The reason for dividing this binary number into group is 4 binary digits are needed for representing one hexadecimal character. So now we have to find the hexadecimal number which is represented by 1011. Similarly, 1110 will represent the hexadecimal. We have to find it. Here also we have to find it. So how to find them? We must write each and every digit in its position, right? So it is 2 to the power 0, 2 to the power 1, 2 to the power 2, 2 to the power 3. Since it's another number, you must start again 2 to the power 0, 2 to the power 1, 2 to the power 2, 2 to the power 3. It's another number, so 2 to the power 0, 2 to the power 1, 2 to the power 2, 2 to the power 3. 2 to the power 0 is 1, 1 into 1, 1. Plus, we have to add the numbers, so plus. 2 to the power 1, 2, 2 into 1, it's 2. Plus, 2 to the power 2, 4, 4 into 0, it's 0. 2 to the power 3, 8, 8 into 1, 8. Add all the numbers together, it is 11. Right? Then look at the second group. First digit, first position 2 to the power 0, 1, but there 0, 1 into 0, 0. Plus 2 to the power 1, 2, 2 into 1, 2. Plus 2 to the power 2, 4, 4 into 1, 4. Plus 2 to the power 3, 8, 8 into 1, 8. So add all the numbers together, it is 14. The first group 2 to the power 0, 1, 1 into 1, 1. Plus 2 to the power 1, 2, but 0, so it remains 0. 4, but they are 0, it's 0. 8, but they are 0, 0. It is 1. So now you have to write the numbers together, but here also there is always a possibility for making mistakes. I already explained that in the previous classes. So because these are hexadecimal digits, you are working with hexadecimal number system. So whenever you are working with hexadecimal number system, you have to be very careful because hexadecimal number system is the only number system which has both numerical characters as well as alphabets. So here, look here, 11 is okay, but 11 cannot be written as 11 in hexadecimal because in hexadecimal you have numerical digits from 0 to 9. The remaining digits, which means from 10 to 15, we have what? Alphabets. 10 should be A, 11 should be B, 12 should be C, 13 D, 14 E, and 15 F. You must remember this idea. So here 1 is correct, okay? So I write it. 14. I cannot write 14 here because 14 is represented by an alphabet, right? What is it? It is E. So it is E. 11 cannot be written because 11 is represented by B, right? So it is B. So 1 EB. Don't forget to put the base. This is the answer. Right now we found the hexadecimal equivalent for the octal number system. So let's take the method again. There is no direct method for converting an octal digit or octal number to hexadecimal. So first of all, I converted this octal digit to binary, right? After that, that binary converted into hexadecimal. Right, so this is simple because these conversions are familiar to you because we already studied, right? Okay, so without taking another example, I will move to another conversion because with one example, we can understand the method. If you want more practices, try spending some time at home and do some exercises as own, right? I don't try with another example, right? So let's take the other one. Right, so remember this is our last conversion. Here we have to convert a hexadecimal digit to octal, right? So this is number 12, hexadecimal to octal. Right, so it is also similar to the previous conversion. So in the previous conversion, I told you that there is no method for converting an octal digit to hexadecimal directly. Here also things are same. You cannot convert a hexadecimal digit to octal directly. So since there is no direct conversion, yes, you have those two options. You have those two methods. What are the two methods? The option A, the first one, you can convert this hexadecimal to decimal first. Thereafter, the decimal should be converted to octal. That is the first method. What is the second method? This hexadecimal has to be converted into binary first. Then binary to be converted to octal. So you have both options as you had in the previous conversion, right? So but here also I will stick, or I will use the second method, which is converting this hexadecimal to binary and then binary to octal. I'm not going to use the first method. I already told you the reason. The reason may not be a big one, but this may be the reason why even your book suggests the second one, right? So let's convert this hexadecimal to octal. Straight away I take a simple example. So 895 base 16. So let's see how to convert this hexadecimal digit or hexadecimal number into octal, right? So what is the first method? This has to be converted into binary. Don't memorize anything. Keep all the things, all those ideas, the relationship, everything in your mind. Now see, you are about to convert a hexadecimal digit into binary. So straight away that relationship in your mind. What is the relationship between hexadecimal and binary? One hexadecimal digit represents how many? 4 binary characters. Or 4 binary characters are needed to represent one hexadecimal digit. So now look here, this is one hexadecimal digit. So to represent in binary, how many binary digits which I want? I want 4. To represent this one, I definitely need 4 digits. To represent this one, yes, I need 4 digits. we have to find out them. So how to find out the binary? There is no other options available, only one option, converting that particular number by binary is base. What is the binary base? 2, right? So let's take that first one, 5. Divide that 5 by 2. So here 2 quotient, 1 remainder. Again divide that by 2. Here 1 quotient, 0 remainder. Again divide that, 0 quotient, 1 remainder. So this hexadecimal digit 5 is represented by 101. But here you have to have 4 binary digits, right? Otherwise you cannot represent a hexadecimal, right? To represent a hexadecimal, make sure that you have 4 binary digits. How many digits that you have now? You have only 3 digits. So we must make them as 4. So add a 0, put a 0 in front. Right? Now value is not changed, but we managed to keep that particular relationship. Right? Okay. Look at the second one, 9. Yes, 9 has to be converted to binary. So 9 divided by 2, 4 times 4 quotient, 1 remainder. Divide again, 2 quotient, 0 remainder. Divide again, 1 quotient, 0 remainder. Divide again, 0 quotient because 0 is small, and put that one here. So they are 1, 0, 0, 1. Number 9, which is a hexadecimal character, is represented by 1, 0, 0, 1. You have 4 digits there. So there is no need for adding zeros, right? Okay. Let's take the first one. Here first is A. You know A represents 10, right? So even though it is an alphabet, you don't need to worry about that. You know the numerical character which is represented by A. So that is 10. So now you have to divide that 10 by the base of a binary. So it is 5 quotient, 0 remainder. Divide again, 2 quotient, 1 remainder. 1 quotient, 0 remainder. 0 quotient, 1 remainder. So what are they? 1, 0, 1, 0. Check, you have 4 digits there too, right? So here also no need for adding any zeros. So since you have all these groups, right? So you have group of bits there, write them together because it is a single number which has 3 characters. Now you have to write them together. So 1, 0, 1, 0, 1, 0, 0, 1, 0, 1, 0, 1, base 2. Remember this is binary number. Still we have to take some steps, right? So maybe we are few steps away, right? To get the final answer. This binary has to be converted to octal. So at this instance, that connection should be in your mind, right? Follow my ideas. This will definitely help for examination. So whenever you are working with binary hexadecimal, that connection must be there. 4 binary, 1 hexadecimal. Whenever you are working with binary octal, that relationship must be in your mind. 3 binary, 1 octal, right? So now this is going to be binary octal connection. So what is it? 3 binary numbers can represent 1 octal character. So we have to form groups from right side. Every group must have 3 bits because it is octal. So from right side we can form the groups 1, 0, 1. This is first group, right? Then 0, 1, 0, that is another group. Again 0, 1, 0, another group, right? At the beginning you have 1, 0, 1, right? We have to find that octal single character which represents 1, 0, 1. Here also we have to find the single octal character which represents 0, 1, 0. Even for others we have to find that, right? So how to find them? 2 to the power 0, 2 to the power 1, 2 to the power 2. it is, since it is another number, it is 2 to the power 0, 2 to the power 1, 2 to the power 2. It's another number, 2 to the power 0, 2 to the power 1, 2 to the power 2. 2 to the power 0, 2 to the power 1, 2 to the power 2. Right? So power of 2, 0 power of 2. So it's 1 into 1, it's 1. Plus 2 to the power 1, 2. But 2 into 0, it becomes 0. 2 to the power 2, 4. 4 into 1, it's 4. Here 2 to the power 0, 1. But 1 into 0, it becomes 0. 2 to the power 1, it's 2. 2 into 1, 2. Plus 2 to the power 2, 4. 4 into 0, it's 0. Next, 2 to the power 0, it's 1. 1 into 0, 0. Plus 2 to the power 1, it's 2. 2 into 1, it's 2. Plus 2 to the power 2, 4. 4 into 0, 0. Finally, 2 to the power 0, it's 1. 1 into 1, 1. Plus 2 to the power 1, 2. 2 into 0, 0. Plus 2 to the power 2, 4. 4 into 1, 2. Add the numbers. So here it's 5, right? It is 5. Here it is 2. Here it is 2. Here it is 5. Now write them together because it is a single number. We divided the single number into our convenient. Now it's the time to write them together. So this is going to be 5225 base 8. Hexadecimal number A95 has an equivalent value in octal, which is 5225. Both of them are equal, but one is in hexadecimal number, the other one is in octal number. So this is how a hexadecimal number system is converted to binary, to octal. Remember the method. First step, you have to convert this hexadecimal to binary. After that, that binary to be converted to octal, right? So this is the conversion. So now we finished all those 12 different conversions. Understanding these 12 conversions, remembering these 12 conversions is very, very simple. If you follow my methods, if you follow my ideas, it's very simple. Because, we studied all these 12 conversions. Now, all these conversions seem to be easy. At the time when you are studying, maybe at the time when you are watching this video, these two conversions may be simple because the method, the steps, everything is stuck in your mind. Maybe think about the examination. You will have to face the examination after months. So even in that examination, you can be asked with only 4 conversions, so 4 questions. So out of 12 conversions, you have to remember only 3 or 4. If you don't follow my ideas and methods, definitely there is a complex. You will be definitely be confused. But if you follow these ideas, whatever they ask, how many questions which they ask, doesn't matter. You can remember the methods and everything. There is no confusions at all. So please keep them in your mind and take some time for practicing, right? So with this, we can conclude today's lesson and meet with another video lesson, right? So thank you for watching.